Okay, so we're going to review some stuff that we learned in our last section of notes. Sorry, I wanted this to be over 4. I had an 8 in there, and that one is not one that we've learned how to do, but 7/4 pi is one that we've been able to do. So this is not quite 2 pi, right? This would be like, if you do this as a decimal, this is like 1.75 pi. So that'll get us to pi. That's 1.5 pi. 1.75 pi is going to be right here. Now, since that's a quarter of a pi, and we know that's going to be a quarter of 90 degrees, that means this is a 45-degree reference angle, making up our reference triangle. From there, we always know our radius is 1, and you should know these are root 2 over 2 every time. That's the beauty of understanding your special right triangles. So now from here, identifying your sine and cosine shouldn't be too bad. It is a good idea to mark which of these are positive and negative. So this goes to the right, so that's positive. This goes down, so that is in fact negative. So now when you say, all right, what is sine of 7 pi over 4? Sine is the opposite over the hypotenuse, so it's going to be the negative root 2 over 2. And it's over 1, but you don't have to write that. Okay, and then the cosine of the 7 pi over 4, that's the adjacent over the hypotenuse, so that's going to be just root 2 over 2. And there we go. That's the idea of this, is understanding the reference triangle and then being able to identify these. As you've done quite a few of these, you're probably starting to notice that these are the same every time. If you know it's a 45, then you know these are your answers. You just got to identify whether they're positive or negative. And if it's 30, 60, 90, it's got specific answers too. So as you do more of these, you start to get to the point where you can answer these even without drawing a picture. So if you get to that point, that's great. Usually I draw the picture, just kind of make sure I check it out. All right, this says if cosine theta is 5 over 13, what is sine of theta? Use Pythagorean identity. So Pythagorean identity is the one that says sine squared theta plus cosine squared theta equals 1. All right, so if we're going to go that route, we don't know the sine squared theta. That's what we're going to be working on. Cosine, we do know, so that's going to be 5/13 squared equal to 1. So that's 25 over 169. Keep this as it is. All right, so we're going to subtract that over. So sine squared theta, this is 169 over 169. So if you take away 25, you're going to get 144 out of 169. And I gave us a nice one here that does work out really nicely, because a nice one that works out nicely. When you square root this, these are both perfect squares. And we get that sine theta is 12 over 13. Now, on this problem, I gave a bit of an error. I didn't indicate where this would be. So at this point, the best we can really say is we know it'd be, we don't know if it's positive or negative. It's always one or the other. So let's go through and talk about the quadrants. And so we know where sine and cosines are positive and negative. So in this case, in all cases, sine is always based off your y value, because no matter where you draw your reference triangle, let's pretend it's right here. Okay. If this is your reference triangle and this is your x and this is your y, sine is always opposite over hypotenuse. So it's always the y. No matter where it's drawn, the part you're drawing, if you know if it's here, is still the y. And if it's here, the part you're working with is always the y. So every time it's the y whenever you're doing sine. So what you basically have to be aware of is these y's are always positive. So if it's in the first or the second quadrant, this will be positive. And if it's in the third or the fourth quadrant, then your y's will be negative. So right there, but depending on what quadrant they tell you it's in, like for example, if this one says, what is this, in the fourth quadrant, or in fourth, that's a terrible way to write it, but whatever. If it says in the fourth quadrant, then your answer would be, oh, this has to be negative. This would be a negative 12 over 13, and that'd be our answer. The same sort of rules apply for cosine, but with the x's. So remember, your x is this part. So when you go to the left, your x is negative. And when you go to the right, your x is positive. So if you're in quadrants 2 or 3, your cosine is always going to be a negative value. And if you're in quadrants 1 or 4, then your cosine is going to be a positive value. Okay. So yeah, that's pretty much it. So normally these problems will specify what quadrant it's going to be in, so you can specifically say whether or not it should be positive or negative.